This video is going to be about organizing data. Now, you can at this point be given what's called numerical or categorical data. Numerical data always has numbers. Categorical data will never have numbers. Now, here are some hints and some tips to follow for organizing your data. When you're given numerical data, you always want to order it from small to big. And it will help if you cross out numbers as you are writing these from small to big, because you will have repeating values. So that way you know you wrote that number down, not another one which it matches. The next thing you're going to need to know, which is called the class width. To find a class width, you will take your highest minus your low and divide that by the number of classes, then round up. Now, when I say round up, or when you read in your book to round up, that usually means round up to the next whole number. I emphasize usually because there are some times where you might get a value of, say, 7.25, and you would round that actually to 7.3. But there are other times where if you have a result of 7.25, you'd actually round that up to 8. Now, it depends on the data, and when you start creating the table, that is when you will start to figure out if you need to work with the decimal value rounded or the whole number rounded. There's no real trick to just know how to do it every single time, but usually you will be rounding to the next whole number. So you're usually safe doing that, but if that does not work, keep in the back of your mind, maybe I should try rounding the decimal portion, not just the entire number up. Then you have this thing called a class midpoint, which uses the symbol x sub m. That is found by taking your upper plus your lower dividing by 2. Now, this can apply to classes or class boundaries. You just have to read what you're asked to find or focus, and then take the upper and lower of that itself, each one, because there will not be just one class or just one class boundary. You will have multiple, which you would have to find the midpoint, if requested, for each and every single one of those. Now you have this thing called class boundaries. You will find a formal definition of class boundaries in your book. And for that, you will notice that it says essentially you're adding 5 or 5 above, 5 below. What I give for this is I always say to quote-unquote add 5 and quote-unquote subtract 5. I put that in quotes because you're not literally adding 5 or subtracting 5 whole values, but let's do some and show you what it looks like. So I want to find the class boundaries of these. So 45 and 72. What you do is you go out one more decimal place than what you're given. So this would then change into 45.0 to 72.0. Now, from that decimal value I just wrote, that is what you subtract 5 from or add 5 from. Subtract is always on the left for low, add is always on the right for the high. So I will subtract 5 from this 0 place, which would cause me to have to borrow. So that would give me 44.5. Add is always easy because you're just adding on. And here would be the boundaries, 44.5 to 72.5. Now, the boundaries, in the grand scheme of this, they are just that. They're boundary lines or boundaries. They are there to help make sure your data is separated. You go one more decimal place than what you see, because if you use the values and the data decimal places you are given, you might have one of those actual values and not be able to determine where that value literally lands. If you go out one more decimal place than the date of which you are given, you can easily say, oh, 45 is going to be inside of here, because this is from 44.5 to 72.5. If I have the value 73, it's definitely outside of this. Now, another way to look at finding boundaries, and you'll notice throughout this course that sometimes you will want to, or it will help you to think of things in a more practical sense than more of an algebraic sense. The number you started with right above what's circled, yeah, it's 45.0, but when finding boundaries, it might help to think of that as 450. What's 450 minus 5? That's going to be 445. What's 720 plus 5? 725. And then you just put in the decimal points where they land. Now the next one we have is 35.4, so I will need to add a decimal. So 35.40, and that is going to go to 37.3, but I need to add a decimal, which would be 3730. Now you might notice, or I hope you picked up on how I'm verbalizing these numbers. I am not saying 0.40, 0.30. I'm saying 0.40, 30. And you will want to do that throughout this course because you're going to have a lot of decimal values that you're going to have to list and maybe even repeat or talk about. And if you chunk the numbers into groups of 2 or 3 when saying verbally, it makes it so much easier to understand and so much easier to follow. Definitely apply that. That's also why if you are rattling off a phone number, it's easier to know and understand the digits you're being said if the digits are said in groups of 2 or 3 than single digit at a time. If you're told single digits one at a time, it gets harder to understand and or differentiate, especially if you have a repetitive number following itself or very close to following itself. So back to boundaries. So I'm going to look at this as 40. It's on the left. Subtract 5 from 40, 35. Add 5, easy. 35. Done. There are the boundaries. Again, looking at this from a more literal sense than the algebraic sense will make it much, much easier to where you don't have to always run to a calculator to do a very simple calculation. Now here, I see 2 decimals, so that means I'm going to need 3 decimals. So the 33 will become 330. The 24 will become 240. 330 minus 5. 325. And then if you add 5 here, that will be 245. And those are your boundaries. Not too bad. Just have to remember, put in an extra decimal place, and that decimal place you added in is what you will be actually subtracting 5 from or adding 5 to. Okay, so now constructing a frequency distribution. And this really refers to numerical data. When constructing a frequency distribution, given numerical data, you're going to first want to determine the classes. Now this does actually work for categorical as well. Categorical, the classes are usually whatever different results you're given. For numerical data, you usually will be told the number of classes, or you should be told the number of classes. Then you will want to find the highest and lowest values Find the range, which equals your highest minus your lowest value. Select the number of classes desired. Again, you should be told that. If you're not, usually the amount of classes you're going to have are going to be somewhere around like 4 to 7, and it depends. Because what the classes do is they split apart all of your data. So the bigger number you choose for the number of classes desired, the more spread out your data is going to be. So if you have too many classes, what that means you need to do is you need to use a smaller number for the number of classes. Then you will find your class width using the formula which was mentioned prior. Select a starting point, and here, yes, there is some ambiguity. It will happen often with this course. The starting point can be the lowest value or anything below that. There are some times when you have your lowest value being some weird, nasty decimal number, and you might want to use just the whole number right below it. Sometimes that will work, sometimes that will not work. Again, you don't know until you try it and you run through the whole process. There is no shortcut in knowing it before you do anything. But as I mentioned with the class width, usually emphasized, you will use the lowest value given. Then you'll add the width to get the lower limits, find the upper limits, find the boundaries, tally your data, and find the numerical frequency from the tallies, then find your cumulative frequencies. Now, when you are creating frequency distributions, I am going to ask that you show these the exact way in which I'm doing them in this video. Do not do it any other way, even if it shows a slightly different way in your book. Do it the way I show in this video, please. If you're unsure, contact me with what you have. Say, I'm not sure if this works, and I will give you further direction from there. Okay, so here we have some data, and this looks like numerical data. So it says the data shows the maximum wind speeds in miles per hour recorded for 40 states. Construct a frequency distribution using 7 classes. And here are all the numbers. It's a lot of numbers. So what you would want to do here is you will want to list everything from small to big first. So that's our first objective, which must be accomplished here. We have to list everything from small to big. So you look for your smallest number. It's 48. And you start going up from there. Next, it looks like it's 53. And you have another 53. The next you have is a 59. Another 59. And this is why I said it will help if you literally cross these out so you can differentiate which of the 59s you have wrote down so far. Next we have a 62. And you might want to use a pencil when doing this because it's highly likely you're going to skip a number and then figure it out 2 or 3 numbers down the line and have to go back and shove it in. And yes, you are going to want these listed one next to the other because what's going to happen in a lesson not too far from now, you are going to need these back to back. You're not going to want to use little arrows of showing this number shoved in or this number shoved in because that will make those objectives even harder. So use a pencil when listing this so that way if you miss something you can erase and rewrite. So after 62, we have 63. Two 64s I see. Third 64. 67. Second 67. I see a third 67. '68. 69. I see a couple 70s automatically, 2 of them. It was 71. And right here, I found I missed a 70. So that's where, yeah, I need to start moving stuff around. Okay. So I have two 72s crossed out. Let me double check those. That's one of them. Two of them, and yes, I've been eyeballing this one, the third one. Okay. Next we have 74. See two 75s back to back. And I missed the 72. So 1, 2, 3, 4 72s, double check it. One of them, two of them, three of them, four of them. Okay. After 75, I see 76. Another 76. Another 76. Three 77s. And I put those there because I noticed right now I missed the 75. Which I'll make this place a 75 for that guy there. Double check them. There's 175, 2 75s, 3 75s, 1, 2, 3, good. So after the 77s, I have 78, 78. And then after those, it looks like I'm in the 80s, so 83. Looks like 85. 87. and lastly 92, 93. Now what I also did here is I tried to keep this organized to where I have everything lined up, top to bottom. All the numbers pretty much line up. I don't have more numbers in one row than I do in another row. The reason I did that is so I can easily double check myself to see if I missed any numbers. So how many do I have across here? I have 13 across. 3 rows of those, which gives me 39. One more extra there, which means I have 40 numbers. Now let me double check that with what I have going on here. I do have them all because actually right here it says 40 states, so every number says, hey, there should be 40, which means yes, I do have all of the data. It's going to be suggested for you to do some sort of double check, and when you're listing numbers, to do it systematically and in an order like this, so that way you can double check to see if you happen to have missed any numbers as you were running through this process. So now we can actually get going on this. So what we want to do next is identify the lowest and highest. Okay, that's pretty easy now. My low is 48. My high number is 93. From those two, I can find the range. High minus low, 93, minus 48 is going to give you 45. Now I can find my class width. Which equals my high minus low, which I actually did here. So it can also be looked at as your range divided by your number of classes. And that's why you find these in this specific order. So you have 45, and how many classes? 7 they asked for. And whenever you're writing your fractions for this class, please use horizontal bars. Do not write any fractions for this class at all, ever like this. Don't ever write them that way, because this could actually be misinterpreted. This could look like 4 and 5 divided by 7, a mixed number. So please, whenever you are writing any type of fractions for this course, always use horizontal bars, never use slashes. So you'd punch this into a calculator, see what it would give you, which gives you something about like 6.4, and like I said, usually what would you do? You'd round it up. So we're going to say that's going to be 7. Okay? Now we can actually start to create the frequency distribution, which you will need is I have class limits. Give yourself some space. You have boundaries. Tally, frequency, and cumulative frequency. Now, sometimes you will see in your book lowercase f. That's fine if you want to use a lowercase f. CF, shorthand cumulative frequency, is perfectly fine as well. So, class limits. I need a lowest. I said you usually start with your lowest value. Now, I can start with 40 if I want. It might work, it might not. I could use 45, I could use 47, but this is really my cutoff. I can't go above 48. I'm going to start off with just 48 because I said that's usually the way this will work out. Now, you use the class width. Class width is inclusive. What that means is I have one value already counted out of those 7, which is 48. What will help a lot of you out is literally counting this on your fingers. So get out your fingers and put one finger down, and that's 48. Another finger down, 49. Keep going until you get to the 7th finger. So you have 48 for 1, 49, 50, 51, 52, 53, and then 54 is your 7th. No, you are not going to add 7 to 48. And if you read carefully above for what to do, it said if you were to add, that gives you the lower, or in this case also the upper. It's not going to give you lower and upper. It will give you only lowers or only upper limits. Now, these are inclusive, meaning if you have the number 54, it's right here. It can't be in the next one. So what you do for the next class limit, go up by 1. Or also you can look at this as, what's 48 plus 7? 55. Now instead of counting from here, now's where you can actually just start adding. 54 plus 7 is going to give you what? 61. Add 7. 68. Add 7. 75. Add 7. 82. Add 7. 89. Add 7 again. 96. And when do I add 7 again? No. Why not? Well, there's a couple reasons. One reason, what's your highest value? 93. You've definitely already been able to consider or enclose the number 93 in one of these class limits. Also, how many classes were you supposed to find? It said 7 of them. It just so happens here width and number of classes were the same. Please try not to get those confused. So 1, 2, 3, 4, 5, 6, there are your 7 classes. Now you notice how I only did the upper, I did not write in the lower. Well, here's why. Once you have this upper written in, notice 54 then 55. So if this is 61, this is 62. 68, so 69, 76, 83, 90. It's easier to add to the upper all the way down and then fill in the lowers. Now boundaries. Give some space for the boundaries. Again, that's quote-unquote half below, quote-unquote half above. So I'm looking at this as 48.0. Or, what's 480? Minus 5. That's going to be 475. Put the decimals there. Add 5. That's easy. 54.5. Now with these guys, you do have overlap. Well, not really overlap, but you have a handoff. Whatever's the upper is the next lower, and so on and so forth. So I'm going to do this the exact same way, which is I'm going to just worry about the upper all the way through and then fill in the lower. So what you can do here is, again, you can add 7. Or you can just look at all of these guys right here, because notice 54.5. 61, it'll be 0.5. Because you're adding a half to all of these. So this is pretty easy to go through and just fill in. and then you just take your previous upper to become that next lower. All right. So there are the boundaries. Why do the boundaries match from high to the next low? It's the same thing with property boundary lines. They touch each other, always. If you see a fence, those two separations of property with that fence, they touch each other. There is no physical separation or empty space between. The empty space between are for your class limits. Your boundaries is just saying, hey, this is like a buffer zone between those limits. All right, so now to tally up the numbers. So what I'm looking for is any and all numbers from 48 to 54. And this is also why you want to start off by listing these from small to high. So 48 to 54, 1, 2, 3 numbers. That's it. It's pretty easy. 55 to 61. Just 2 numbers. If you want to mark them off, that's fine. If you don't want to, that's fine. Doesn't matter. Sometimes it just helps me to mark them off so I can see where I left off. So now I'm looking for 62 to 68. Now you might be saying, well, what about this? Why aren't you looking for these halves? Because again, those are my buffer zones. These are inclusive, 62 to 68. And that's what I need to look for. Whatever you're tallying says, I have this many values in this interval. So from 62 to 68 now. And it looks like I had 9 of those. 69 to 75. Looks like 13. And you notice I'm using different crossout patterns, again, so that way I can sort of see where each of these groups of numbers landed, and to create some separation in case I missed something. I can more easily find out where I was grouping things. So 76 to 82. This looks like 7. Okay. 83 to 89. And 90 to 96. Just 2. Frequency is really easy. You're just making these into numerical form. 3, 2, 9, 13, 7, 3, 2. Cumulative frequency, this is why I stressed as I'm showing you in this video, do not do what your book does. Your book likes to make this completely separate quote-unquote table for cumulative frequency. It's not necessary. Just keep it all together, just like this. You put this cumulative frequency somewhere off to the side, will take off. Keep it together. So cumulative frequency is tallying up all the way down your frequencies. So how much are you starting with? 3. Then you have 2 more, so 5. 9 more, 14, 13 more, 7 more, 3 more, 2 more, and something's wrong. How do I know? Because I'm supposed to have 40 values. I only got 39. Something's missing somewhere. So I was counting these, counted up 40. Okay. Where we are off is from 76 to 82. There should actually be 8 of those values. So this is why else I marked them off in different patterns so I could easily figure it out. So then when we had 27, the next would now be 35, plus 3, 38, 2 more, 40. Now later on, we will actually have use for frequencies, cumulative frequencies, and boundaries. So, but just for right now, the cumulative frequencies just to make sure, hey, we have all of our data, all of our numbers. Okay, so now this is going to be a categorical frequency distribution because all we have are categories, nothing else. So we don't have to list anything from small to big because there are no numerical values. There is no finding class width because that's a numerical value. There are no boundaries because that's a numerical value as well. For categorical frequency distributions, all you will have are the classes, then you'll have your tally, give some space, then you'll have frequency, and then you will have a percentage. Now this says a survey was taken on what drink people prefer. The choices were W for water, P for pop, ST for sweet tea, UT for unsweet tea. Make a categorical frequency distribution and then answer which class has the most and fewest values. Okay. So my classes are just the options, nothing more. And it does not matter the order of which these are listed. You don't have to have W first, P second. You just need all 4 of these is all that matters. Okay, so now tallying. Waters. Looks like I got 17. Okay. Pops. Same thing, 17. Sweet teas. It's 24. And now the unsweet teas. And you notice I crossed none of the unsweet teas out, because again, what I did here is the W's I slashed out one way, pops the next, sweet teas another way, so then anything which is not crossed out should be an unsweet tea. Now to find the percentage, what you're going to need to do is add up all of these values. So punch in all those added, and you should get 64. Now to find the first percentage, what you would do, so the percentage of water would be 17 divided by 64, and change that into a percent, which should give you about 27%. This is the exact same, so it'd have to be 27 as well. So then for sweet tea, that would be 24 divided by 64, which is going to give you about 38. And two ways you can take 6 divided by 64, or if you want to add these and say 100 minus that, it will still be sufficient, as long as you show your little work down here so I can have the idea of how you went or probably got your results. Meaning if you actually do the work for that unsweet tea percentage, make sure to write 6 divided by 64 so I know, oh, you divided to get that. If I don't see this, then I would assume you added these and subtracted that value from 100. Now if I divide here, since I got that written down, that gave me about 9. So this would be the categorical frequency distribution. Now don't forget to answer any questions which might have been asked, which is a common running theme throughout this course. A lot of the times, and it's not for every question or every exercise, but on some of these they do ask, hey, we want you to answer this question after you've done this work. So now that we've done this work, it says which class has the most and fewest values. I'll just go to the next page so it can be clearly read. So the most choice here is actually a tie between water and pop. The fewest choice here is unsweet tea. All right. If you have any questions, always contact me. I'll be more than happy to help you out. If not, I'll see you in the next video.